it's my great pleasure to invite Praka Gupta to talk today. So Praka is a PhD student at the Language Technologies Institute at CMU. And if I remember right, his undergraduate was at the Indian Institute of Technology in Roorkee. And yeah, thank you for being here. Looking very much looking forward to hearing what you've got to say. So Praka, over to you.
Thanks, Peter. Thanks for the introduction, and thanks for having me here. And thanks everyone for being here. So yeah, I'll talk about my work today on like enhancing reliability and continual improvement of neural dialogue systems. As Peter introduced, I'm a final year PhD student at LTI-CMU. My advisor is Professor Jeffrey Bigham. I did my undergrad at IIT Roorkee in India, and then I was a research fellow at Adobe Research India for 3 years, and then I started my PhD at CMU. My general research areas, especially the applications area, have been dialogue systems and text generation. So in this talk, I'll start with some research overview and motivation. Then I'll talk about one particular deep dive in my work on DialGuide, which is aligning models with developer intent. Then I'll talk about another work, like a short manner, target guided response generation, and then summary and future directions of more recent work and future directions. Okay, so some motivation about like my work. So dialogue systems or conversational systems are automated systems for interacting with users through natural language interface. They're powered by innovations in machine learning. Conversational systems have replaced traditional ways of human-machine interaction with more natural, human-like dialogue, transforming user experience by making them simpler and personalized. Dialogue system generally involves steps such as understanding, planning, and generation, also like predicting actions and planning through natural language. So the advancement in natural language and dialogue technologies, followed by development of assistants such as Siri, Alexa, and then the more recent arrival of LLM-powered models like ChatGPT, Bard, Bing, ChatGPT, Claude, have made language model and dialogue technologies ubiquitous to the public. Dialogue systems generally fall into two classes: task-oriented dialogue agents, which can do tasks such as giving directions, finding restaurants, etc., and open domain chatbots, which are designed to do more social and chit-chat type of conversations about any topic. With the more advanced LLM-based assistant, their applications have gone from traditional use cases like finding restaurant, customer service, to and have slowly started to become more tightly integrated to our daily life and work as creative writing assistants, coding assistants, tool to get information, plan stuff, to learn languages, and even to get advice for social situations. Tracking the development of dialogue systems, traditional dialogue systems were more rule-based and non-neural machine learning systems. Developers would write rules for language understanding and templates, which would be fired for specific situations, which would make them easy to debug and then safe for deployment. Thus, rule-based systems were popular in early industry products, even till the last 2-3 years. However, the dialogue flow of these systems are predetermined, which limits the system and make them inflexible to unseen scenarios. So due to the growing availability of dialogue opera, advancements in deep learning and compute, neural dialogue systems have achieved considerable success. Large pre-trained language models, such as GPT models currently used to power neural network-based dialogue systems, produce increasingly fluent and interesting responses for novel dialogue contexts. These systems are more flexible compared to rule-based systems and show great quality and diversity in generation. However, they are data-hungry systems and require large and clean corpus in order to function reasonably. They are black boxes and difficult to debug and control, and any form of control costs additional data. Lack of control makes them susceptible to unintended and unsafe response generation. We will delve deeper into these aspects in more detail in this talk. Through my research work during my PhD, I showed that the development of natural and effective dialogue response control mechanisms, robust evaluation metrics, and dialogue safety mechanisms from dialogue models can improve the reliability of neural dialogue systems for real-world systems. So my work is broadly divided into like improving robust evaluation and control generation. So dialogue evaluation metrics are crucial for dialogue systems as they can improve the reliability by ranking the model outputs or filtering out poor outputs. They can help to differentiate between diverse dialogue strategies and explain which features of the dialogue systems are important. Furthermore, the quality of the training data for models can be controlled by filtering and curating the data using the evaluation metrics. Creating reliable evaluation ranking metric is challenging because they're hard to define, have multitude of factors the response quality can depend on. They're very often domain and application dependent with poor transfer performance and are susceptible to spurious features which trying to correlate response coherence and appropriateness with content similarity. To give a brief overview of my work on enabling more robust and fine-grained evaluation dialogue systems, my first work was in 2019 to improve evaluation using multiple references instead of a single reference response. Then I worked on creation of synthetic adversarial negative responses to create robust neural response ranking and evaluation metrics. I next focused on creating benchmarks for factuality in both dialogue and summarization, and, and recently investigated the use of large language models and the role of instruction tuning and models size and types for evaluation across fine-grained quality metrics for both dialogue and summarization. In terms of evaluation control generation, I want to improve. I want to give dialogue developers the control to create more engaging and agenda-driven system, so that they can also perform control the system in terms of the topics the system can talk about, the tasks they can do, and their more knowledge and style condition. And we want to prevent bad behavior such as being offensive, biased, or creating non-factual responses. Controlling generation is challenging. There are challenges in defining what we want the control for. A developer would want to avoid control mechanisms that are ambiguous or too specific, such as keywords, and would rather prefer mechanisms that are natural, intuitive to specify, flexible, and interpretable. In my work, I propose control using mechanisms such as using examples, instructions, target sentences, etc. So I worked on a variety of techniques to ensure the model follows the developer agenda, enhance engagement. The first work was about controlling generation through exemplars, where we would edit templated responses to make them coherent to a novel context. In this example, we could edit a templated response, which is like eggs are beneficial to your body, to a more vegan-friendly response, which is vegan food can be good for your health. In target-guided dialogue response generation, which would be one of the work I will present here, we would control the response using a target sentence, such as if we want to say, I like to travel to new places as the target in my conversation. So the task is, how do I steer the conversations towards this target and write a coherent response to steer the conversation towards this target. Next, I worked on instruction tuning models so that they can follow any instruction in a zero-shot or few-shot manner. And this work was done specifically for dialogue. I also will give a brief overview. I will also talk about DialGuide, where we aim to align dialogue model behavior with developer guidelines. So conversational agents are among the leading applications or interface of AI, and they generally take the center stage in AI-related demonstrations. However, their failures are also very noteworthy. Like Microsoft became known for being racist and using offensive language when openly deployed, and similar stories were also heard when Bing ChatGPT was released. This serves as a warning that we need to solve safety issues in this area before thinking about deploying them in the real world. Therefore, I have worked on techniques to ensure the model generates safe and factual responses. They range from investigating in-context learning, from improving safety in dialogue, using guidelines to prevent unsafe behavior for situations the system is generally bad at, using explanations to improve factuality, and finally improving summarization by factually collecting clean annotations across multiple tasks, like one paper we just put on archive yesterday. So I'll next move on to the deep dive of my first work, DialGuide. This work was done last year. It's about aligning dialogue model behavior with developer guidelines. Let's say you train a very capable language model or chatbot and make it as safe as possible before deployment by training on clean data and adding checks for toxicity. But there could always be scenarios where a model can encounter which the developer has not planned for. For example, in this conversation, it is possible that the model has not seen any training data to handle this toxic context, and the toxicity filter may also not be able to find any issues with it. Now your model is already deployed. How can we fix or patch it at deployment time and do it quickly? Maybe we can train with more data through supervised learning or RLHF, but that is a time-consuming process, as you need to carefully collect data and fine-tune the model. Also, fixing this issue through training can break the model on other related scenarios. So we need a mechanism that is easy to apply, is reliable, allows natural control, and does not require retraining the model. So to fix the issues mentioned, we propose a new approach for controlling dialogue system behavior, which we call DialGuide, where we can adjust model behavior using natural language guidelines from developers. It's not just toxicity we aim to address. We might also want to specify how the model should behave in certain situations to drive better engagement, for example. In this example, let's say the conversation is about someone asking if you found it hard to learn piano. To drive better engagement, the developer could have written the following guideline. If a person asks if you had trouble learning a musical instrument, tell them a story about learning it. The response could follow the guideline to say, no, I had it easy. My tutor said that I learned it the most quickly among all our students. So this guideline-based response could be a more engaging response than if the model had just said, no, I didn't find it. I found it easy. So a guideline consists of two parts. The if condition part specifies which context the guideline is relevant to, and the action part specifies what the response should contain. It can contain information about the dialogue act, emotion, key phrases, causes, reasons, contrasts, anything. The action part can be very specific, from saying that you found it easy to learn the piano to very abstract, tell a story about learning the piano. The if part of the guideline is also its main distinction from a typical instruction, where the if part is supposed to match the context and help in retrieval, and it is generally more abstract than a typical instruction. At deployment type, the system would look up existing set of guidelines to find the ones which are relevant and then follow them to generate the response.
Hey, Prakhar, I had a question on that previous one. So you maintain these if-else conditions like in a large dictionary of some kind?
Yeah, guideline bank, let's say.
Guideline bank. And how do you manage its consistency over time? Like,
yeah, so that is actually kind of a future work, the consistency part amongst the guidelines, and it is a very important aspect. The scenario we imagine is that you deploy the system, you find issues in terms of engagement and in terms of toxicity. A developer would find these issues and write guidelines to fix certain issues in like either very specific manner or very abstract guidelines. And over time, we believe that a next iteration of the system would find like how can a new guideline conflict existing guidelines. So that's like a part of future work.
and just one follow-up question: How do you do this matching? Are you going to talk about it?
Exactly. Yes.
Okay. All right.
Yeah. So, so guidelines provide better control. Steer the conversation towards comfortable topics, can help avoid novel unsafe situations at deployment time, and fix common system mistakes, creating more engaging responses. Some advantages of using guidelines are they are natural sentences, they are configurable and can be added, deleted, edited, etc. The model does not need to be retrained for new guidelines, so they can be easily written and deployed instantaneously at deployment, even by a non-technical stakeholder. So you do not need retraining, you do not need you can just add test time, just write a very natural language sentence, and the model has been pre-trained to be able to understand any new guideline. So coming back to that question, this setup consists of 3 tasks. The first task is guideline selection, in which, given a conversational context, we find the most appropriate guidelines from a guideline bank. The second step is guideline-based response generation, where given the context and let's say the top selected guideline, we generate the response which follows the guideline. And the third task is guideline entailment verification, which predicts whether a response follows or violates the guideline. So this whole set of 3 tasks form a pipeline which can help us find the guideline, generate the response, and then ensure whether the response followed the guideline or not.
Hey, Prakhar, can I just read that example, or could you read it? Because
Okay.
I couldn't read it.
Yeah. So the conversation context is about, I have been playing piano for a long time. So the person says, did you find it hard to learn it? So in our guideline bank, we can find guidelines like, if a person asks you if you had trouble learning a musical instrument, tell them a story about learning it. That is a correct guideline. But a similar looking guideline, which is, if a person says they found it hard to learn piano, empathize with them, will not be a relevant guideline. A relevant answer using that first guideline is, no, I had it easy. My tutor said that I learned it the most quickly among all her students. Now, let's say you used the guideline to generate a set of candidate responses, let's say 4 responses. You can use this, the third task, to score between 0 to 1 to you can score each response between 0 to 1 about how much entailment is there between the guideline and the response. So the B we already saw, and the D is also like I had a great teacher, so it was easy.
Can I interject, Prabhar?
Yeah.
So looking at the guidelines, it seems like they're extremely specific. Like, for example, and it seems like that a very high level feedback could have been applied here, that okay, if someone has difficulty about learning anything, you would probably just say being sympathetic and just say that how to learn it better, for example. I mean, it doesn't have to be very specific to piano.
Yeah.
So I'm just wondering that I mean, how would we collect those kind of guidelines? And if we have those generalized guidelines somehow from a developer, which is probably possible coming from a human, would your pipeline work or not? Yeah. But
yeah,
you could answer it later. But just the putting the
yeah, this part will also come, but like a short answer is that the guidelines can be very specific, which is like it could have been like when someone asks if you had trouble learning piano, for example, to a general thing. If someone asks if you had trouble learning something. Exactly. So yeah, we have considered all different scenarios. Even our training data also consists of different abstractness and specificity. And yeah, I'll talk about it a bit more. Yeah. So some of the in this work we have to handle the following challenges. So first is we want to prevent retrieval of irrelevant guidelines, because guidelines specify how to act, and if you get an irrelevant guideline, retrieve an irrelevant guideline, you can like lead to other issues. We want to be robust against irrelevant guidelines. So there could be still situation in which we get the wrong guidelines. So we want to create a model which is robust against that. Third is we want to we want a model that can learn to realize abstract concepts to specific details. For example, the action part in this example was tell them a story about learning it. So a model should be able to realize how to what kind of a story it can tell given this context. So yeah, this is the typical pipeline, which consists of a guideline bank. The first task involves, given a dialog context, find the top guidelines which are relevant. Given the guideline and the context, generate some set of candidate responses. And then given the context and the guideline plus any response candidate, score whether each score which guidelines are entailed, responses are entailed by the guideline. You can use that for re-ranking, for example. So this work combines the following research areas I generally explore. One is to ensure better control over the system. I worked on instruction tuning, so this work is actually kind of a follow over instruction tuning. Another thing I care about is fixing models through feedback. So I treat guidelines as a way of incorporating developer feedback for future iterations of the model. And this work also involves common sense and abstraction. So I'll go over each task and talk about.
Sorry, could you go? Can I ask a question?
Yeah.
Right before this slide?
Yeah.
So what are the models that you're using here? So your response verification model is just like is it a BERT model or BERT classifier?
No, it is an instruction tune model, but it does classification.
And where do you get the data to train that model?
So for all these three tasks, we collect data for fine-tuning existing instruction tune models.
Okay. And how many examples did you need for doing this?
Our data set varies because instruction tune models are already pretty good at general common sense, etc. We the range of guideline context, etc. we use for training the response generation model, for example, is only 10,000. Actually, training is 6,000 instances. Guideline retrieval needs more work because that's we use traditional models like dbut, dpr, etc. So that has around 50,000 and more instances. And verification model is still, again, small. It's about 12,000
and the response generation, which kind of models is that?
So the response generation model is again an instruction tune model, a T5 based model. T5 type model.
Is it planned?
It is a flan T5 model instruction tune for dialog using my previous work, but it is like a 3 billion parameter model with T5 architecture.
Thank you.
One question here.
Yes.
So for your first model, the task one, the guideline retrieval, is that I guess I'm going back to this question that came up earlier about abstractness of the guidelines.
Yeah.
So if there's a guideline, does it typically apply in your data to multiple scenarios, or is it are you training only for the like one-to-one correspondence?
Yeah, so the guideline bank, actually, the way we collected the data, it has different levels of abstractness, the set of guidelines we have. And typically, a guideline which is more abstract can actually be retrieved from multiple scenarios. But we would like, if we have a specific guideline for a specific situation, we would like to score that higher than the more abstract guideline. So that's what we want. Okay, so let's first talk about how we've collected the triplet of guideline, responses, and context, guideline, and responses. So we actually augment two existing dialogue data sets, a blended skill talk, which consists of general chit-chat type conversations, and pro-social dialogue, which contains safety-critical conversations with rules of thumb. So we have two mechanisms for collecting this data. So the first mechanism consists of given a conversational context and a response, write the guideline. So both the conversation context and the response come from the, for example, blended skill talk data set. We instruct the annotators to write a guideline, which so the task is hard because sometimes a worker can just simply copy words from the response and write them in the guideline. But we ensure that we have different variants of specificity in this in the guidelines by giving instructions and examples to the annotators. But still, we still are very dependent on the type of response we already have to create the guideline. So in the second mechanism, to improve the variety of guidelines, we only show the context to the annotators and then ask them to first write a guideline and then use that to write the response. To assist them, we provide hints about what to write in the guideline and hints about abstractness, such as they can use phrases like appeal to morality, show concern for X, change the topic to Y, apologize for something, deny something, ask rhetorical questions. So these are more abstract concepts rather than being very specific about what's happening in the conversation. That helps in getting more abstract guidelines. So they first write the if part of the guideline, and they write the then part, and then they use the guideline to then write the response. Yeah. Okay, so that was about collecting the triplet of guideline, context, and responses. Let's talk about guideline retrieval. So how we go about this is the following. Let's say we have this conversation. I've never been to Seattle, but I love the coast. I like to take road trip when I can. Being a coordinator helps me, offers me the ability. The last part is me too. I like to stop at interesting places along the way. One time I spent a week following the Oregon Trail. So what we do is, using the data we collect in the previous step, we train a model to generate guidelines for any situation, and specifically only the if part. We don't care about the then part in the retrieval. So we use the language model, I'll train language model and generate a set of guidelines for this conversation. These are like real guidelines generated by the model. Then we show these guidelines to the annotators and ask them to say yes or no, whether this guideline is relevant towards the end of the conversation. Like if you want to write a response using a guideline, this guideline should generally matter more towards the end of the conversation. So for example, if a person talks about taking the car on road trips to Seattle, which came in the beginning, it's not relevant anymore to predict an action. But on the other hand, saying something about Oregon Trail is more relevant. So these are hard cases because a language model is creating these guidelines using the whole conversation and some noise we added. About 30 to 40% of the guidelines we generate are actually predicted as being relevant by the MTech annotators. So these, the ones which are predicted as no, become hard negative for training a retrieval model.
Quick question. How are you getting the language model to generate these situations? Are you using few shot prompting, or are you fine-tuning a model to do this? Or
yeah, we use a large actually, that's the 3 billion parameter model, which is instruction tuned, like Flank-T5 kind of model, and fine-tune it on the data set we have, which is around 7,000 to 8,000 triplets of guideline, etc. So it does a pretty good job in understanding how to generate a guideline with that data.
And this is the data you talked about in the previous slides that you were getting from Turkos. Is that right?
Exactly.
I see. Got it. Thanks.
Okay, so next part is guideline entailment verification. So the task was that given the context and the guideline, tell whether the response followed the guideline or not. So this is easy. What we do is we show the annotators multiple responses for a context and ask them to mark the ones which follow the guideline, giving us binary annotation per response candidate. The responses shown here have either been written by a human annotator or generated using a language model, again using the data we collected in the first step. This is this data is going to be used to train evaluation metric or the entailment verification metric. Now the problem is that negatives collected in the response selection task again can have low semantic overlap with the guideline, which incorrectly leads to the model paying attention to topical similarity. For example, if a person was talking about playing an old gaming system, talk about your experiences with old gaming system. So here, like, yeah, I was so young when it came out. I can't believe it's been 20 years. So it's this one, the model can pay attention to keywords like Nintendo, etc. to do this task and not actually learn the correspondence between a guideline and responses. This third response does not have a lot of matching keywords and topics with the guideline. So we want to prevent this case where the model is just paying attention to semantic overlap. So we collect adversarial responses to learn features beyond topical similarity. We show a response. To do that, we show a response that follows a guideline. So this is the conversation. This is the guideline where it says if someone tells they are anxious, empathize with them and tell them what works for some. And then we also show the MTAG annotator the response written in the previous step, like the response which follows the guideline. And then we ask them to corrupt this response so that it does not follow the suggested guideline. It violates the guideline. So it says, like, I'm sorry to hear that. I feel the same when presenting at work. So how we do that is we, again, spent a lot of time getting it right. We showed the annotators different strategies like change entities, invert the semantics, change the action in the response, change event attributes, change relationship, and remove some details in the response. So that makes it possible to make the response adversarial. We asked them to minimally edit the response so that now it violates the guideline. Using all this data collection procedure, this is like the summary of data set we collected. So we have around 5,600 training. We have two data sets. One is dialogue, blended skill talk, which is chit chat dialogue, and the other is safety, augmenting the pro-social dialogue data sets. So we have around 8,000 for response generation, a lot for guideline retrieval, and around 20,000 for entailment, and a smaller set for the safety data set. Let's talk about some results. So we discussed the main results here. So for guideline retrieval, we fine-tune DPR models and also Roberta type models for re-ranking. First, we find that DPR models can be tuned for good performance. We are reporting map at 3, recall at 3, MRR here. DPR models, there are two kinds of data set we use. There's silver and silver plus annotated. So silver is just simple. It consists of two parts. So one is using the data we already collected. We actually train a model to create guidelines, which we talked about earlier. So we create a lot of data using that, not just like the 30,000 we collected. We create fake guidelines for for existing conversations to a range of around 100,000 to 200,000 and call it silver data. But that data is noisy. So but we just show that like using silver data, we can create this kind of retrieval model for any new domain. That's the point we're trying to make here. And then using annotations, especially the hard negatives, is like the second step we do. So the re-ranking model, re-ranking using Roberta model on top of DPR improves the results over DPR. And training of hard negatives improve performance. So these columns are without hard negatives, and this is with hard negatives. So that is a summary of guideline retrieval, where we get MRR and recall at 3 above 80, around more than 80, around 88, I think. Second is about response guideline entailment results. So first, we show that task is hard. Simple analyze models or word overlap kind of models do not work well. Even zero shot with some 25 kind of model do not work well. fine-tuning, instruction tuning models help. So instruction tune models, zero-shot are not able to do this task well, but just fine-tuning even with the small amount of data we have actually helps. All these models are instruction tuned, fine-tuned using our data. Second, adversarial test set is harder. As I mentioned, like we created adversarial test responses to test the model for features beyond topical similarity. So you see here, when we don't train on adversarial tests, the difference between adversarial and normal test set is big, and that gap reduces when we actually train on a small set of adversarial responses. Finally, dialogue response generation results. So again, we test a variety of models using few shot LLM models, not using guidelines, or instruction tune model. We found that the few shot models like LLM few shot generally did not perform that well, mainly because they were copying stuff from the guideline a lot rather than realizing the abstract concepts into more specific things. That is, we haven't tested this model with ChatGPT, GPT-3, because this work was actually done before that. Sorry, GPT-4, because the work was done before that. Next is the no guideline model. This one creates coherent responses, but they are not controlled. So a model which dialogue models are good. Generally, they can generate good coherent responses, but we want to add the additional concept of control, which comes in our work. We have variations of our model, which are these multi-step, retrieve, robust, and DialGuide. There are three variations. So this one is an upper bound, the last one, where we use gold guidelines. We don't retrieve the guideline. These two models are retrieval-based models. So first we retrieve the guideline and then generate the response. So the difference between retrieve generate and retrieve robust is that for training retrieve robust, during training, we sometimes train using incorrectly and randomly selected guidelines to generate the response. So by doing that, we are teaching the model that if it gets an incorrect guideline, it should be able to ignore the guideline and then generate the response generally. We also train the model that if we don't feed in the guideline, which will happen in a lot of cases, we won't have any guideline, that it should be able to still generate a response. So just take the context and then generate the response. So we found that the retrieve robust model does pretty good. It has very coherent responses, but of course it will suffer on entailment because we are teaching the model to ignore the guidelines sometimes. Finally, we have results. Sorry.
What's the multi-step model that's also doing pretty well?
So the multi-step model is just a case study to show that a model can generate its own guideline when needed. And so if a guideline is not shown to the model, it can generate the guideline and then follow the guideline to generate the response. We are only doing this to add this additional notion of interpretability. Okay, instead of just taking a context and generate the response, we want to be able to interpret what the model was thinking before generating the response. So this multi-step model, in case it does not have the guideline, also just generate the guideline and then the response. So that's only needed if we want interpretability.
So this is not constrained by a guideline bank. It can generate any guideline it wants, but it's trained on guideline bank, I guess.
Exactly, yes, that's the case.
Okay.
Ideally, we will have a combination of a model trained on guideline and being able to generate the guideline when it is not present. But this one just generates the guideline by being trained on the guideline bank. Yeah.
Prakhar, when the model is additionally generating the guideline, do you see interesting cases where like it does not make sense?
Yeah, okay. So these are not very large models I've been working with. What we found was the model was not really great at generating abstract guidelines. It was kind of generating more specific guidelines than we intended, and then just kind of following those specifics in the response itself. So that's why it's not up to the mark, I would say, the models we used till that point.
I see. Maybe we should make meta guidelines then.
Yeah. I like to talk about that, like one of the future works. Yeah. So next big test case was safety scenarios, where we work on pro-social dialogue scenarios where the contexts are toxic, and the model is supposed to generate safe responses for those contexts. So again, we found this incorporating safety data improves safety score. For example, when we don't use guidelines, works poorer than when we have the guidelines. Even few short OPT models works pretty well in terms of safety. The orange bar is the safety we have added here. Models not trained on guidelines, a rule of thumb, have low safety score. So the no guideline one has lower safety score than the models which have guidelines. But please note that the model which does not have is not using guidelines still is very safe because it has been fine-tuned on pro-social dialogue data. So we are just showing comparison between being fine-tuned on safety versus having guidelines about safety. And the final is that, oh yeah, it's just like the other generation trends are very similar to the previous model, where the few shot model is still poor and fine tuning definitely improves the performance. So this kind of work kind of reiterates some of the my general feeling that having more quality data is generally better in even fine tuning smaller models. So better quality data is always good in any task you do, even if few shot models are already good. I'll just show you one example of the model generation. I'm only 24. I'm alcoholic. Do you want to quit drinking? Yes, I'm ready to quit drinking, but I can't do it on my own. So guideline was, if a person says they want to quit their addiction but can't, tell them to get help from a professional. So the generated response is, it's good that you want to quit drinking, but it's important to get help from a professional. Alcoholics can be very difficult to treat, so it's best to seek a professional help. So the situation which happens sometimes is, like, this is both a good and a bad example. Good in the sense that it is elaborating on what has been said, but also it is copying things. This guideline does not leave much to elaborate on because it's just saying get help from a professional. So it's reiterating that, but it is also trying to reason about why it is good to get professional help. So DialGuide enables guideline-based dial control, leading to safer and engaging responses. We propose benchmark performance and models for guideline retrieval, generation, and verification. And we show that fine-tuned, instruction-tuned models generalize well to new guidelines and context. So,
Great question.
Yeah.
So I guess to get a bigger picture, how big is the guideline bank and how many situations or dialogues do you have?
Okay. So I showed this table in the beginning. We are working with these two different setups. One is for safety and one is for chit chat. And the number of guidelines we have in training is these. And for the response entailment verification, we have around 20,000. For retrieval, we have a bigger set, around 50,000. So that task is hard to retrieve from 50,000.
So it's so like it's in the test set you have about 10,000 guidelines to retrieve from.
Yeah.
And so what's the data set size?
Yeah. So for retrieval, it is like this. It has to get. We are measuring recall at 3 and recall at yeah, amongst all these. Yeah.
Is there, like, sorry, maybe I'm still confused on that part. Is there one-to-one correspondence between? I guess maybe like what I was imagining was, it's in the way you motivated the work. You have a system that can be run on thousands of dialogues, and maybe through feedback, a guideline bank is developed that might have like 500 guidelines or something.
Yeah.
And that it would be the guidelines abstract, and then the number of dialogues that they covered is way larger than the guidelines.
Exactly.
Is that the setup here, or not so much? Is it more one-to-one?
It is the setup here, but I think it's very task dependent. So there's a trade-off between writing abstract guidelines and specific guidelines. Specific guidelines do not happen, like specific situations don't happen a lot, but the developer might actually want to write more specific guidelines so that the guideline does not bleed into other situations where it should not be used, and to keep the diversity of responses high. On the other hand, we want to also sometimes write abstract guidelines so that they have better coverage. So it's a trade-off, and I think it's up to the developer how they want to design it. Yeah, but typically, I imagine that we will not have more than, like, say 1,000 guidelines in one domain, and what we want is better recall in terms of, like, whenever the guideline is needed, it should be used, and still, like, we don't want to unnecessarily use a guideline when the model can do well without using the guideline. So yeah, these are like subtle things, and like more analysis is needed in terms of what's good for a domain.
So
Okay, maybe I missed this. Oh, sorry, Bodhi, go ahead. I think I
Yeah,
get you this.
I have one or two questions actually.
Yeah.
So, one thing that you already have these goal responses written, followed by the guideline, for example, given a context. And so, why don't you just like train a dialogue model with this new set of goal responses, which are collected using the guidelines? Why I'm saying that, because you also end up having lots of supervised model in the end. So I was just wondering that even if you say started initially that this is like post deployment, but you could just like train one model instead of like 3 models that you have in your pipeline. So, and
So-
if you, yeah.
So the motivation was that at test time, we don't want to retrain the model because like that can take time. We want a quick fix. Let's say Bing ChatGPT was deployed and then people found an adversarial way of pinging it some way to get some offensive response. At this point, you can write, the developer can write the response it needs to do, for that kind of a situation, but there's no guarantee that we will be able to train the model to actually get to that response, because model is still free to do most of what it wants. Just training using like say 10 responses for that situation won't fix the model. On the other hand, we have trained a very general model which can understand guidelines. So if I just write a new guideline for this situation, the model actually can find that guideline in its guideline bank without retraining on this new type of guideline. So we are making a more general model which can understand guidelines rather than training the model to behave in a very specific manner, because that is hard, as I mentioned. Does that kind of answer?
Yeah, I mean, but it also requires like more abstract or generic guidelines as opposed to like the specific guidelines you have, right?
So yeah, I think we at least again reiterating the point that the model has already been trained. The only thing the model developer now needs to test like writing 2-3 different specificity of guidelines and see like what specificity it needs, so that now this situation is covered.
Okay. Yeah, I think that somehow answered the question. Thank you. And another question, I think you mentioned somewhere that many times there may not be any guidelines, for example. So,
Oh yeah.
first of all, I think you might be setting some similarity threshold, I guess, beyond. You don't take that. But ideally, you do call the engine of collecting guidelines at every response. Is that correct? I mean,
yeah. Every context we would do retrieval, and then we have a threshold of whether any relevant guideline was found or not beyond that threshold.
Yeah, maybe it's like a future work, but have you thought about anything like being smarter here? Maybe like you don't really need to do that for every response, for example, and maybe only some response needed that, because this is very expensive running this at the test time, right? In terms of
you're right.
Yeah,
you're right. I think definitely it makes sense. You look kind of the model can answer like is it good at answering this kind of a situation? I think if you can find this kind of a model, that kind of model, that can help with that. I think that can stop prevent the expensive retrieval step.
Yeah, cool. Thank you so much.
That's a good suggestion.
Okay, very quick question. I might have missed this, but how do you test generalization to new guidelines?
Oh yeah, actually, it's not in this presentation, but let me just tell you. I think I have one of these. Is it here? It's an ablation study we did. It's in the paper. So what we do is for generation specifically, we train the model on the chit-chat data set and test it on safety and vice versa. And we found that the model generalizes very well beyond in these two domains.
Got it. So the context is different and the guidelines are different. Okay.
Yes. So that just shows that the model is actually understanding the guidelines and not the data. Like this. Yeah. Okay. Oh yeah, I'm excited to talk about future work of this work. So first thing is we want to explore DialGuide for new applications and domains such as task-oriented settings. So response selection and generation still suffer from semantic overlap biases, and better pre-training and incorporating common sense knowledge can help. So for example, if there is a guideline, like if someone mentions suicidal thoughts, tell them that they can improve things and have a better life. Our model still does this, like you need to talk to someone about it, you can improve yourself and have a better life. So if you have these kind of response in our data, and if our model is generating this is not what we want to do. We want the model to elaborate further rather than copying things. Second is we might want to incorporate more complex and logical if condition matching for guideline retrieval. Like if a person, you might want to write more complex guideline. Like if someone wants to travel a destination low crime rate and plenty of vegan food, then recommend something. So right now the guidelines are like a simple clause and simpler, but we might want to make them more complex, especially for task-oriented settings. Next is explore guidelines in the context of constitutional AI. That's kind to answer one of the questions people had earlier. So like meta guidelines. So for example, constitutional AI from Anthropic work had these kind of principles, like choose the responses that answers the human in the most friendly and socially acceptable manner. So these are very abstract, and the model might not know how to realize them in practice. So I have a set of ideas about this. So first is we can break down the principles in a set of more specific guidelines for more specific scenarios. So either a human or a human working with LLM can come up with these scenarios and guidelines. Like a friend scenario could be a friend shares some bad news with the AI, or sorry, a user shares some bad news with the AI. Guidelines could be like express empathy and understanding in case of I'm really sorry to hear that. It might be tough for you. It can offer support. It can avoid minimizing the situation. And these are more specific guidelines for the same abstract principle. Second is they can work with the human to discover positive and negative specifications of how to react. So if a user said, I just lost my job and I don't know what to do, positive behavior is to say, I'm really sorry to hear that. It might be tough for you. Is there anything I can do to help, or you want to talk about? I'm here for you, etc. And negative behavior is that that's not a big deal. You will find a job soon. Don't worry about it. And third is to learn diffusible reasoning over principles and guidelines. So a defeater for that principle could be that the friend explicitly mentioned, user explicitly mentions that they prefer distraction or humor rather than discussing the bad news. And diffusible reasoning would involve, based on the new evidence, the AI can revise the initial inference to align with the friend's preference or for distraction or humor. Yeah, so that's how I think this work aligns with constitutional AI. I have not enough time, so I'll just directly jump into the future work section of my work instead of the second work. Sorry, I have to skip this. Yeah, I'm skipping the second work, and okay, let me talk about some future direction. So I want to enable learning beyond traditional paradigm of imitating static text. Scaling is not enough, and for some domains, getting expert human annotations can be impossible or expensive. As humans, what we learn, think, or do is refined through trial and error in an iterative and feedback loop. This fact, as well as some of the latest work in NLP, has shown us that feedback and interactions can improve both human and machine performance. And ChatGPT and other LLMs, with their multi-turn conversational capabilities, naturally allow feedback and interactions. So I want to take this paradigm further and improve LLMs and enable them to have better interactions and learn through feedback. So I imagine this framework where a model can interact with a teacher that can be either a human, a user, or a developer, or an LLM nowadays, or an interactive environment. The teacher can provide feedback in terms of label preferences, re-ranking, explanations, labels, anything. The model can use the signal then next to learn supervised through supervised learning, RL, distillation, or whatever mechanism. So learning through a feedback and interaction can improve complex reasoning, as like we have done in the latest self-refined work. We can incorporate reasoning for things like exploration and learning. For example, we can incorporate feedback and interaction to tell the model what to learn next and what to explore in, let's say, a simulated environment. And similarly, when it is learning, we can incorporate the reasoning of why something happened, the explanations, and the other kind of reasonings in the learning itself. Next is the model self-improvement, which I'll just talk about next, the self-refined work. Next, we can augment creativity of both the human and the machines by combining their unique strengths. And this has additional effect of reducing degeneration, hallucination, improving safety, reduce violation of specifications. So like I was talking about model improvement, I think most of the people here are familiar with the self-refined work. A lot of people are here already. It's about iterating refinement with self-feedback, where the model generates something in the first iteration. Then current models, LLMs, are capable to introspect about the output, generate feedback about what's good, what's not, how to improve it, and then the model can use that feedback to improve itself. I'll just go through one example to show what it means. So there's a context. I'm interested in playing table tennis, and GPT-4 generates this response. I'm sure it's a great way to socialize and stay active. The model can generate feedback along different dimensions, like being engaging, factual, coherent, user understanding. So engaging says that the model response does not contain information about table tennis or how to play it. And it's not user understanding because it does not attend to user's needs and state of mind, what the user wants from this conversation. So it uses this feedback to generate a better answer, which is, that's great to hear that you're interested in playing table tennis. It's a fun sport that requires quick reflexes and good hand-eye coordination. Have you played that before, or are you looking to learn more about it? So the model actually improves upon itself. The first response is great, but the refined response is even better, and that the model can like self-improve. The next set of work I'm excited about is to keep on working on my thread of alignment, safety, and faithfulness. So I care about aligning models with the task goals and developer intents, and the set of work related to that are along instruction tuning, RLHF, and better pre-training strategies. Then about aligning with users' needs and values. So I think about, and I've been working on improving pragmatic understanding and theory of mind, and improving multimodal and contextual understanding of the model so that they can understand the user's state of mind better. Last is the improving faithfulness to factual knowledge through better annotation, better adversarial training, better pre-training strategies, like providing, for example, providing more context during training, which makes the model more faithful. This is the work I was talking about. We released it yesterday. It's called USB Unified Summarization Benchmark, where we given some summaries, given a Wikipedia page, we start with a summary which has errors, and we ask annotators to mark spans of which things are hallucinated. And we also ask annotators to select the sentences for each summary sentence, which could be evidence. So we have all these annotations, and then we create the benchmark of tasks such as abstractor, extractor, summarization, evidence extraction, factuality classification, unsupported span prediction, fixing factuality, and controllability tasks like topic-based summarization and multi-sentence comprehension. I also have work on improving factuality of response using explanations. Yeah, I alluded to this one, like how I imagine working more in the area of constitutional AI and incorporating feedback, merging the field of constitutional AI, guidelines, and feedback in my future work. I don't know if I have time. I'll leave time for questions, but I wanted to talk something about pragmatic reasoning, but maybe I can talk later. Yeah, I'll open up the floor for questions, I think, at this point.
Great, thanks. Yeah, that's questions from people.
Oh, I think that's
Prakal, how about you show us that last slide on pragmatics? That would be quite interesting to see, actually.
Oh, okay, let me do that. So the part about pragmatics is that LLMs still struggle with handling real-world communication scenarios requiring contextual understanding and pragmatic reasoning. So I want to explore and understand the importance of contextual understanding, common pragmatic challenges faced by the language models, and potential solutions for improving their pragmatic capabilities. So the challenges are that language models often struggle with understanding the context and background information necessary to interpret a given utterance in real-world scenarios. The other challenge is the amount of written text in pragmatics is very limited. It does not contain pragmatic information stated explicitly. Also, there is a lack of communicative intent being present in written languages and books. Second is language is generally ambiguous and vague, which makes it difficult for LLMs to interpret and respond to certain types of situations, especially that require situational, physical, and social reasoning. Finally, there are cultural and social nuances, and language models may actually lack knowledge of cultural and social nuances, leading to misinterpretations or inappropriate responses in certain contexts. They also struggle with domain-specific language and knowledge. So I want to work on both measuring the understanding of models and improving it. So we want to benchmark if LLMs are sensitive to users, speakers' situations, emotions, intentions, beliefs, values while interpreting the utterances. For example, they can infer that a speaker is being sarcastic or ironic or being humorous, etc. So let's consider this situation. Person A and person B are in a car. Person B is driving the car at high speed. It is dark outside and raining heavily. Person A says it is raining very hard. a language model can just think that person A is talking about weather, but the contextually inferred intent is that person A wants person B to drive more safely, and that information is coming from this additional context of being dark and rainy outside. It also involves diffusible reasoning, like what additional context information can strengthen or weaken the understanding about an utterance. So forget, like, if it was just about driving the car at a high speed and a person says it's raining hard, it's more likely they were talking about the weather or small talk. But if you add the additional context, it's dark outside and raining heavily, the model should have more confidence about it being about the person A saying to drive more safely. So we also want to understand what the listener is, what the listener's assumption is about the speaker's intent. For example, if say person A says something to me, what am I inferring about their intent? So that can help in resolving misunderstanding, conflicts, building trust. And then, like, there are directions about improving pragmatics in terms of thinking about alternate interpretations of actions. Like, listeners can't always infer the intent of the speaker with certainty, but the LLM has more avenues. Like, people are more biased in terms of what they're more informed sometimes, but sometimes they're also biased about what the other person can mean. But LLM has more avenues to think about and reason about multiple possible interpretations of a user intent. So when someone says, "I'm not feeling well today," person B could say, "I'm sorry to hear that. You should take some medicine and rest." But the LLM can do better. "Oh, that's too bad. Are you feeling physically sick, or is it more of an emotional thing? If it's physical, then something like this. If it's emotional, maybe you need to talk to someone or something." So yeah, like, I'm just saying that LLM can do better if it has like less biases and can have multiple interpretations. Adapting to user feedback and preferences, LLMs can be trained to adapt their language model output to users' feedback, beliefs, and preferences. Feedback can be about corrections, evaluation, rating. Beliefs can be political, religious, scientific. Preferences can be about tone, style, language, cultural, dietary, etc. Yeah, so that's general theme about pragmatics direction. Questions?
That's great. And I'm just thinking about those pragmatics. So to answer some of those questions, you'd have to probe the model then to understand. I mean, how do you know what the system understands about the user's intent? Would you imagine probing it to have it answer explicitly what it thinks the user's intent is?
Yeah, so the direction I'm thinking about for that is to actually use things from psychology literature and first find the dimensions of what the model should be thinking about: beliefs, values, social situation, emotional state, and all those aspects. And then let the model write a summary about what has been its interactions, and then write, okay, these are the possible beliefs, values, etc. Have some kind of notion of confidence over them, and then use that in any action it takes.
Great. We have time for one last question.
I can ask one. So have you looked into incorporating multiple levels of guidelines into the same response? For example, you might have I think you touched upon it a bit, you might have a general guideline that, respond politely or be considerate and all that. That applies in all situations in a way, even without matching the condition. This is how you want the person of the chat thing, right? And then in addition, there's a specific guidelines.
Yeah, that makes sense. I actually imagine this scenario that we start with this abstract guidelines, and the model, if we want more interpretability, the model will break down this abstract guideline into more specific guideline or its interpretation of that abstract concept. We'll write it down explicitly and then condition on it to generate a response. And the abstract and the specific guidelines, like the model can also retrieve both the abstract principles and the specific principles. But the only thing I'm worrying about is, like, if the guidelines conflict each other, then what happens? But yeah, I think a future iteration of the system should work with multiple guidelines and multiple levels of specificity. We have also seen the conflict happening with feedback systems also. The model can have conflicting feedbacks. So same principle, I feel, same issues.
I could imagine a meta-reasoning system that reasons over all the guidelines to try to work out, which ones seem to be outliers and which ones fit together. And so the system, meta-reasoning could help give the system a coherent set of guidelines or a coherent value system that it's working with, rather than having conflicting things.
Exactly. I actually kind of want to develop a tool for that, which lets the human or developer explore how to write new guidelines for new situations and how to fix existing guidelines, how to consolidate guidelines, how to make them specific. So I envision this kind of a tool.
Because there's a problem, you know, in human communication, we give suggestions and guidelines to each other, and often we state them in an overgeneral way and then have to go back and refine them when we realize there's special cases where they don't apply.
Yeah. That happens a lot with social people. Like I form guidelines about how to react to specific people, and then I constantly change them.
Right. All right, Prakar, thank you so much. We've been asking you questions throughout the talk rather than putting them all at the end, which is fine. That's the best way of doing it, is having an interactive kind of presentation, which is great. Let's all give Prakar a round of applause to thank him.
Thanks a lot. Thanks for being here and listening to my talk.
All right, Prakar, thanks. And I think I'm talking to you next, so we can just take a 1-minute break and dial back in.
Okay.
All right, thank you, everybody.
Thank you.
Thank you. Have a nice day.